Alright class, today we're going to be talking about applications of conic sections, and we're going to see why we actually study conic sections. And because in a lot of this different situations in nature, conic sections are popular graphs or functions that we're using. And so we're going to focus on actually only two conic sections because those are brand new, and then in class we're going to be coming up with equations for conic sections based off the real life situations. So first we're going to talk about a parabola. And as you can see, a parabola here, we know what it looks like, but a lot of times parabolas are used in shapes that reflect light or distribute light. If the light comes in a way so that it's symmetric to the axis of symmetry, the light is going to be reflected based on the parabolic shape to one point, which is the focus point, as we can see here in this picture. So as the light comes in, it's going to be reflected to this focus point as well, and that's because of the parabolic nature of the curve of the light, or whatever the deal may be. And other way around, sometimes they'll start light and let it shine from the focus, and that means it's going to pop back out. So we'll look at examples like that in the book. So 3D solids that are formed by taking a parabola and just rotating it around its axis of symmetry are called paraboloids of revolution. And so common examples are satellite dishes, searchlights, telescopes, and they're formed in such a way that based off a parabola so that they can allow the light either to be reflected in or to reflect the light out. Satellite dishes are reflecting the signal out in a more focused area, receiving a signal from an actual satellite. So the satellite basically in the air sends a signal, and it hits the satellite dish, and the satellite dishes collect the signal and then distribute it where it needs to go. The next one we're going to talk about conic is ellipses. And ellipses have two foci, where a parabola only has one foci. And ellipses are really common in types of architecture, and in the sense like, and they have is that if you are around one foci point and you say something, if the shape of the ceiling is an ellipsoid, then that sound bounces off the ceiling and hits directly towards the other foci. And so at Rice University, they have this wall where you speak in the physics building. You can ask Dr. Harris about it. The whispering wall, where you can speak into one of the little ellipses, and then maybe 10 meters away, someone who's standing under the other ellipse can actually hear what's going on. And that's because the ellipsoid have that property where that the sound will bounce back towards them because it's a constant difference. Constant sum. And then some popular uses of ellipsoid or examples are actually in orbit. And if you guys remember from, I guess, astronomy, I don't know if you even have that, Kepler originally thought that the world originally thought that the Earth was the center of the universe, and that every planet in the sky revolved around the Earth in a circular motion. And then it was only Kepler who said that doesn't make sense. And so what he found is that they're actually the Earth revolves around the sun in an elliptical motion, where the sun is one of the foci points, and therefore the planets rotate around the sun in an elliptical manner. Okay, and so ellipses are often found in science and engineering. We don't really know that much about hyperbolas. I don't really remember how much they're used, but sometimes, if you ever notice when in your if you see lightning and then you hear it thunder like a few seconds later, well, that's because the speed of sound moves faster than the speed of light. The speed of light isn't faster than the speed of sound, so that's why you see, and that moves in a hyperbolic notion. And last but not least is a circle, and I like circles for this reason. Let's say, for example, the FBI, when they ask people, they're looking for someone who is missing, and they say, where was the last place a person was located, and then they average in how far that person could have traveled. And the area they use for people to search is a circular region, because if this is where the person was last spotted, and they could only travel at most a certain length of a certain distance, then they have the search area. They assign people sectors of the circle to search, because if a person can only travel this far, then they can only go in much this region, and that's the region that they look based off of the radius. So conic sections are used often in real life applications, and in class we're going to spend a lot of time going through examples of, number one, figuring out which conic section the situation calls for, and then writing an equation based on the information given of the conic section. And that's going to be it. So it's a short video. Apologize for my tardiness, and I will see you tomorrow.